Okay, good morning, good morning, good morning. Today we are going to do something a little fun. Hopefully you'll enjoy it either by watching it or you can actually do this one at home. This is a very easy one to do. The hardest part is going to be finding something that will be similar to a regular old test tube. So something long and cylindrical such as this. I picked up these test tubes. I actually got 24 of them. They are from Party City, about $7 I think for 24 of them. They're similar to test tubes. They're plastic. They're for parties, you know, shot glasses, but we're not promoting using them for that purpose. We're promoting using them for science. So what we're going to do today is we are going to create some sugar mixtures, and we're going to use those to create a density, what's called a density column. You may have seen Steve Spangler do the density column where he used like a bunch of different materials like oils and things like that. This is similar to that, but this is using powdered sugar or any sugar really and some warm water, and we're going to see how this goes. So I need a measuring cup. That's a cup right there. I don't know if my little cups are going to hold an entire cup of water. Well, let's start with a half a cup and see how that goes. I'm going to take it off of the rim here so it's easier to work with. Alright, so we got the old half cup. Alright, some water over here. It's warm. That'll help dissolve the sugar faster, especially if you're not using powdered sugar. So let's see if we can get this into the cup. Yeah, so mine's only going to hold about half a cup. So I'm going to cut my recipe in half. I think I'm going to pour this over top of the water. The great thing about kitchen science is it doesn't have to be quite as accurate as I would have to be if I were working in a lab where the results are critical. Could make a huge difference. So these are variables I would control for, right? Control for how much water I use and how much sugar I use. The temperature of the water could be a variable. Probably not in this case because we're just dissolving the sugar. So here I have just some basic confectioner's powdered sugar. There's powdered sugar. Already marked my cups, so I've got my blue cup over there is going to take 2 tablespoons, but I said I'm going to half my recipe. So I'm going to do 1 tablespoon. Let's see if I can use this little jimmy here. So I get a nice flat full tablespoon worth of sugar. I do that by sliding it across the inside of the bag. Go. Now the next one is supposed to take 4, so I'm going to do 2. Now what we might end up with is what's called a supersaturated solution, which means it dissolved more sugar than water. So there's more molecules of sugar in there than there are water. Now that'll probably be like the last one, the green. So there's 2. Okay, now we're going to do 3. It's a little bit messy, so you'll have some cleanup to do afterwards. 1. 2. 1 more. Whew, getting sugar everywhere. 3. Now we need 4. This will definitely be super saturated. 1. 2. The nice thing about the powdered sugar is it practically dissolves itself, especially in warm water. 3. And 4. All right. Now we can set that aside. Now we'll stir. Make sure all the sugar dissolves. You can kind of feel it in the bottom of the cup, a little bit grainy, so once that feeling, that texture goes away, you can be pretty sure you've got a nice solution there. Everything's dissolved. You can also see it in the bottom if you're using clear cups. Whew. Now I am using an orange straw for my yellow, but it's because I don't have a yellow straw. Okay, I think that one's pretty well dissolved. And we'll go with my red. Still see some powder in the bottom. Alright, and now what's going to be my green. Yeah, it's going to take a little longer to dissolve all the sugar in this one because there's so much sugar in there. Now, what I want you to do while I'm continuing to stir here is I want you to make a prediction. This is what you're going to turn in as your exit ticket. What's your prediction about what's going to happen when I add these solutions one at a time to one of my test tubes? What will happen? What is your prediction? And part of the scientific method is to predict results, right? And also explain why you think that that's what's going to happen. So I'm going to add them in one at a time. I'm actually going to go backwards. So let's turn them colors. If you're writing down your predictions and your explanation of why you think that that's what's going to happen. Okay, awesome. We are ready to begin. So let's go ahead and take a test tube and start adding some colors. Okay, there's green. Now I'm going to add this very slowly. Getting a lot of mixing going on in there. It's not staying separate. I think I probably put the red in too quickly, or my solution is not a good solution. Maybe because I don't have enough water and therefore enough sugar. But your results may vary if you're trying this on your own at home, which I hope that you are. The yellow seems to be staying separate from the rest. So the yellow and the blue are kind of combining into a green. So I do see some variation. I see some green down here, and pink and green combining with some yellow, I think, making a kind of a purple. Then I've got some yellow, and then I've got a lot of green. So a lot of the yellow and blue are combined, but some of the yellow stayed separate. So the density kind of combined up here. So yeah, not too bad. Let's try adding some color, some more sugar to our green. We'll try another test tube of it. At this point I'm just playing, just seeing what I can do. As it sits, it's kind of getting some more separation, and I can actually see an almost blue, thin blue layer at the top, which is pretty interesting. I'm having trouble getting all this sugar to dissolve in here though. And I'm going to put some more water in my blue to dilute it more. So here's my first test tube. You can see some of the color separation. You can see some red in here, some yellow, green, and then at the very top like a blue. The bottom is the green. And in here it mixed, the green and red mixed, so we got some purple in there. Let's try another. Alright. So why did I start with the green one? Well, it should be more dense because of all this sugar in it. Alright, let's add some red. And so I'm going to try adding it at a much greater angle. Okay, so far so good. Do have some red at the top, some purple in the middle where it mixed. Still getting some mixing. If I could do this one drop at a time, if I had some pipettes or medicine dropper, I would be able to control this much more. See how that settles out a little bit before we add the blue. So far, this is what I've got. Some green, red in the middle, but we've got some mixing, so it's really more of a purple. Some yellow. And we just got to get some blue on top if we can. It's much more dilute, so. Didn't work out exactly the way I hoped, but it does illustrate density and how different densities will float or sink in water. So our green solution is much more dense than the red, yellow, and blue solutions. So I've just diluted the blue even more, just to see if we can get some blue on the top. Not quite. It turns green. Oh well. Hope you enjoyed. I hope you try this at home. If you try it at home, try to snap some pics and upload them into the lesson. so I can see your handiwork, maybe give you a few bonus points for that. And that's a wrap. See you tomorrow.